And that's when we came across what we started calling the exchange trilemma. So between decentralization, capital efficiency, and scalability, every exchange out there right now is only able to get 2 of the 3. First is twin turbo consensus. So we looked at Tendermint, and there were a lot of things that were inefficient with the way that Tendermint was implemented. So we just made it substantially faster. We changed the way that block propagation works. We changed the way that block processing works. And through this, we were able to get down to a time to finality of 300 milliseconds in a load test or multiple load tests that we ran in an internal testnet cluster. So for context, most other ecosystems have a multiple second time to finality. Like even Solana, for example, it has 600 millisecond slot times, but it has probabilistic finality. So one block by itself doesn't get finalized immediately. You need to add more blocks to that chain and that's when it'll get finalized. So even Solana has around 3-second time to finality. And the reason time to finality is important is because it greatly improves the market maker experience. If market makers have a lower time to finality, then they're able to offer tighter spreads, which result in better prices for users. And at the end of the day, we're just trying to build the best infrastructure for exchanges. So that was something that was a really big deal for market makers. The second thing that we did is we were focusing on supporting greater throughput. So we added in parallelization. We're the only Cosmos chain to be making use of parallelization of any kind. And this helped us get up to 22,000 orders per second in an internal load test. So for context, most high performance chains get between 1,000 to 5,000 orders that they can process each second. So say is a magnitude better in that sense. And the last major thing that we did is we added in a native order matching engine. So you can think of Stay as basically a general purpose chain with this native order matching engine primitive built into it. So anyone that wants to deploy vanilla smart contracts, they can. But anyone that wants to make use of an order book based exchange, they can make use of the order matching engine, and that will make it extremely easy for them to deploy. It'll also help them with preventing front running. And the reason we can do that is because these are changes we made at the chain level. So we're able to aggregate every single order, combine them at the end of a block, and then execute them all at the same price, rather than having order 1 get price 1, order 2 get price 2, etc. So these are all optimizations we've made that have helped improve the user experience. And there's also this concept of order batching that says native order matching engine supports. So this allows a market maker to submit one transaction that has multiple orders inside of it. So if you want to update a market on another chain, or if you want to update 50 markets on another chain, you might need to submit 50 separate transactions. In the case of Say, you only need to submit one transaction, and then you can update 50 separate markets. So the chain knows how to just read that transaction and then route those specific orders to the correct markets to update them. So yeah, I mean, at a high level, those are a lot of the things we've done to make Say the best place for exchanges. The fundamental problem with building a rollup on Ethereum is that it just does not scale. And the reason for that is that rollups need to write the data that happened off-chain. They take that data, they compress it, and then they write it to the underlying layer 1. So that is how every single rollup on Ethereum works right now. And every single byte of data that is written to Ethereum L1 right now, it costs 16 gas. So if you do the math, you actually can only support around 6,000 transactions per second if the entirety of the block space on Ethereum L1 is used for rollups, right? But in reality, that's not what actually happens. In reality, there's Uniswap, there's OpenSea, there's a ton of other smart contracts on layer 1 that people use. So it ends up being extremely difficult to even get to that 6,000 TPS. Even proto-dang sharding does not solve this. We did the math with proto-dang sharding, and it actually only comes up to be 6.7K TPS. So in Ethereum, anytime in the near future, you're not really going to be able to get better performance, which is why building a rollup on Ethereum was not the right solution for what we're trying to build, because throughput is one of the most important things for exchanges. And if you're building on Ethereum, you're essentially just capped at around 6 to 7K TPS. The second thing that we considered was shared security. So this would be building a Polkadot parachain, or an Avalanche subnet, or a Cosmos Hub consumer chain. And the fundamental issue there is we wanted to be able to control the consensus mechanism to be able to get the best possible performance and to get the best time to finality. And what this specifically means is that we wanted to be able to tweak the way that blocks are propagated, and a lot of other things around the consensus layer, control the validator set. And that's not something you can do at all if you're making use of shared security. So that's why we decided that shared security wasn't the right approach for us. And that's why we looked into the third approach of building our own sovereign chain. And between to build a sovereign chain, you can either build everything from scratch, or you could make use of something like Cosmos SDK to get up and off the ground very quickly. Building something from scratch honestly doesn't seem like the best approach. Like, you're just recreating the wheel when you could be only making the changes you need to, which is why we started building with Cosmos SDK, which made it exceptionally easy to get a new chain built pretty easily. And then we're able to make the optimizations at both the application level and the protocol level to get the type of performance and user experience that we consider to be important. The other thing that you get with Cosmos SDK is IBC. So IBC is a generic data transfer protocol, which makes it very easy to communicate and bridge between, say, and other Cosmos chains. So given that we're building a trading-focused ecosystem, we want to make it as easy as possible to get liquidity onto the ecosystem. So IBC was another really strong selling point of building with the Cosmos SDK. So yeah, that's why we're very happy that we made that decision. And we originally got started with, initially it was decentralized Robinhood in 2021. Then last year, around this time, we started building Say. We had our first testnet up and running in May, and we're going to be launching our second testnet very soon. So stay tuned for updates around that, but that'll be the right thing for me to be doing. Should I be going into Web3? The advice that I wish someone had told me is that if you're excited about something, then you should just go for it, because you're going to do a much better job over there, and you're going to honestly just have a much greater impact than staying in a place where you're unhappy. And I think this applies to a lot of engineers that are in a place where they feel comfortable when things are kind of okay. It's just substantially better to leave and just start building in Web3, because you're going to have it's going to be a lot more interesting. You're going to have much more learning opportunities. And I mean, honestly, there's a lot of really fundamental problems for solving in Web3 that you don't really get if you're just working at a normal Web2 company. For example, building trustless, permissionless systems, that is an extremely strong value proposition that you just that makes you feel good when you work on something like that. Whereas if you're working at Google, and your full-time job is to tweak the button interface on a different, on one of the Google websites, that doesn't really feel as inspirational. So yeah, I mean, you should just go for it. I think it's just much better to work on something.